This section for the ACT practice test is on trigonometry. This is section 6 of 6, or topic 6 of 6, and again we'll go through easy, medium, and hard problems. Let's look at the trigonometry section and what it will cover. Trigonometry questions cover the trigonometric ratios defined for right triangles, the values, properties, and graphs of the trig functions, trig identities, trig equations, and modeling with trig functions. Let's work through a couple of the problems on the practice test. Here is the first one. In the right triangle below, the side lengths given are in inches. Which of the following expressions equals the sine of angle R? I realize that it's a right triangle, that's important. So we are dealing with SOHCAHTOA, and it's important that you make sure you spell it correctly. Where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Now people will look at this and go, I don't know how to solve that. They haven't given me any letters. They ask specifically which of the following expression equals the sine of angle R. So all they want you to do is test you. Do you understand how to set this up? That the sine of angle R is equal to the opposite over the hypotenuse. So fill in what we know, and that the opposite from angle R, so here you are standing at angle R, this is you. Opposite is going across, like an opposite you, or across the street from you. So the opposite from angle R is little r. And the hypotenuse is the longest side, which is Q in this case. But your longest side is always the hypotenuse. The other two are what we call legs. This would be the adjacent because it's next to, but is not the hypotenuse. In this case, this one would be the opposite. And then you've got your hypotenuse. But these two are what we call legs, and the third one is simply the longest side, which we call the hypotenuse. So in this case, your sine of angle R is opposite over hypotenuse, or R over Q, which is going to be the letter G for your answer. So not too bad of a problem, just a matter of setting it up, making sure that you understand SOHCAHTOA. Let's look at the next problem. It says, from a blimp 1,130 feet above the ground, the angle of the depression to a marker on the ground is 52 degrees, as shown in the figure below. Which of the following expression gives the distance along the ground in feet from the marker point P directly below the blimp? You see the little question mark here? They want us to solve for x. We know this angle is 52 degrees. So we got an angle of depression, and that's your 52 degrees. They want us to solve for x, so let's go ahead. We know that this angle here is 90 degrees. So 90 minus 52 leaves us with 38 degrees. So this angle right here is going to be 38. Now we go back to, because we know we're dealing with a right triangle, we can use SOHCAHTOA again. So we can go ahead and set this up and see what happens. So where people run into trouble first is they go, well, which one do I use? Sine, cosine, or tangent? And how do you know? Well, let's look at the information we have. Compared to the 38, we have the opposite that we're trying to find, and we know the adjacent. So which one of these three, sine, cosine, or tangent, deals with opposite and adjacent? And the only one that deals with both of them is your tangent. So we're going to be dealing with the tangent of 38 degrees is equal to opposite, which I don't know, so we'll just call that x, to the adjacent, which is 1,130 feet. To solve for x, we go ahead and multiply both sides by 1,130. And whatever you do to one side, do to the other. That will cancel that out and leaves us with x is equal to 1,130 times the tangent of the angle of 38 degrees. So in this case, the best expression is going to be A as an apple. Are there other ways of setting this up? Yes, you could have found that this angle was 52 degrees and gone through that way. However, if you look at your possibilities, none of these deal with 52. So you're dealing with this angle of 38 degrees. You can almost use this fact that they keep going with the 38 as a hint in a direction as to which one they would want you to set up. So another question in trigonometry, they like is the SOHCAHTOA. Keep that in mind, and again, make sure you spell it correctly. This one would fall under a hard category for trigonometry. For a specific non-zero value of b, the graph of the y equals sine bx in the standard xy coordinate plane intersects the x-axis at k values of x in the interval from 0 to 2 pi. At how many values of x in this interval does the graph of y equal 2 sine bx intersect the x-axis? People will read that and go, what in the world did they just ask? I quit, I give up. Don't give up. See what happens here. Go back, reread the problem. And there's two things that stand out. Y equals sine bx and y equals 2 sine bx. Once you realize that, and then you look at this part, this just means one revolution, one full circle. That's all that means. So if you look at the equation, what is the only difference between the first equation and the second? It's the fact that it goes from 1 to 2 on our equation. When you do this, or a scenario like this, what you can do is you can use a calculator to help you. If all else fails, is you get your SmartView TI graphing calculator. We'll let this pop up here in just a second. The calculator will pop up. And you walk through and graph each one and just see what happens. But make up a number for b of x. Let me just get this set up. Oh. There we go. Pull this over here. Here's the calculator. All right. So to get this set up, let's go through. And first thing let's do is do second. Quit. I'm going to clear out of that. I'm going to do second y equals. And I'm going to turn all plots off. These should all be off. So just hit 4, enter, just to make sure all the plots are off. Then go to y equals, and let's clear out all the equations that we've got. Just scroll down, make sure you scroll all the way down to the last one, and make sure that there's no equations there. So we want to be up to the top at y sub 1, and before we do that, actually at this point we can type in the two equations. Y equals, let's do sine, and we can do whatever we want. Let's say sine of 3x, and then let's try another one where we double it. It's just 2 times the sine of 3x. People are going to wonder where that 3 came from. I just made up a value for these b values. Just because I know they're the same, so I just make up some number, and let's just see what happens. Now, before we graph, there's something we need to do. We need to change our mode because we are dealing with radians here. We're not dealing with degrees. So we got to go to mode and change this to radian mode. Highlight the radian, hit enter. And then let's just graph and see what happens at this point. Now mine's a little messed up here because I've graphed something else. So I'm going to do zoom, standard, to walk through the graph. Here's the first equation, and there's the second equation. Now if you're not sure how that looks, it looks kind of weird. So what we'll do is we can zoom in. Let's zoom in. So I'm going to go to my table or my window, and let's let our x min be 0. And our x max be 4, let's just say. The scale is 1. The y min, let's go from -4 to 4. All I'm doing is zooming in a little bit just to make it a little bit. And when you hit graph, it'll graph the first equation you typed in and then the second one. Here's your first equation, and here's your second one. Notice the only difference between these two graphs. Just zoom in here so you can see it. Oops. Let's do under the part. Notice the only difference for this one is if you look at this, it goes from, it's the exact same graph, same high area for the high point, same area for the low point, and then high and then low. All we're interested in is how many times it goes through and hits the x-axis. And it doesn't change. The only thing that changes, here's your original, y equals 3x. And then the second equation is y equals 2 times the sine of 3x. All that does is double what we call the amplitude. The amplitude is from here to here. That's the amplitude. Or from here to here for the first one. All it did was double the amplitude. It didn't change the period. The period is how often it takes, or how long it takes before it repeats itself. And in here, it started repeating itself both cases right at this spot. So our period didn't actually change. So I started with y equals sine of 3x. I just made up a number for b, for this number right here. And then I knew the second one was y equals 2 sine of 3x. And this again, the 2, because they said it, they had it 2. And then this b is the same as the one previous, so I just left that as 3. Type those both into your calculator. This is the type of graph that you'll get right here. So let's go back and answer the question. At how many values of x in this interval does the graph y equals 2 sine bx versus sine of bx intersect the x-axis? It's the exact same amount. Both are the same, which we will just call k. Nothing changes. It's the same. Hope that helps. That takes care of 3 trigonometry problems from easy to medium to hard.